We will start exact at 5:05. Just wait. Anybody joining? This is the fourth session. So I think we should start right now. It is 5:05. Let me turn on my camera. So as I think it's beautifully audible. Understood. Check my audio. So good evening to everyone. Welcome to the fourth session of AME 91. It is Production Technology Theory and Practices. So I think your assignment date is next Wednesday. So we start with now. So as you already submitted your assignment for third week, so we start first from that assignment problems. So okay, this is the first problem that we have in the third assignment. So they are mentioning the tool specified in ORS system as follows. The angle is given to, that is phi 7, that is ORS specific structure they are given. In the case the angle in the above tool given as phi, this which is this angle has been changed to 0 degree. The following change will happen in the machining process. So okay, this is as it is ORS. So this will be your I, which is inclination angle, which governs to the how the chip will flow. So according to that, as our inclination angle becomes 0, the chip will flow parallel to the workpiece as the what is inclination angle. So this will be your inclination angle in ORS. So this is your inclination angle. So if this inclination angle becomes 0, that means this will be like your tool position. Okay, because the inclination angle is 0. So how the chip will move? Parallel to the chip flow of the workpiece, which is the first answer. So this is actually what is happening there. As they mentioned, the inclination angle, which is phi, that phi is becoming 0, means this will be the geometry of the tool becomes, and due to which the chip will flow parallel to the workpiece. Okay, as it is mentioned. The cutting force required will be less. These things are not. The chip flow will usually flowing out of working zone. So easy flowing out of working zone is not possible here. The power consumption in this process is increased. So these things are not. Power consumption depends upon your shear angle. So power consumption and these things will not be happen because it depends upon your this angle, that what angle you are actually cutting. So this angle it will depend on the not depend upon this inclination angles. So the main is how the chip will flow because the inclination angle comes where actually the chip is even moving. This is the part where your actual chip is moving even cut. So this is only the correct answer because this is in the slides also. But these all the other things are not related or more appropriate for the whole question. So this will be your correct answer. The force based this doesn't deal with right now in context this doesn't come, but it will come. But according to how the question is set, this is only the optimal correct answer because I understood how the chip will
So,
flow.
so what's the meaning of the 5 degree enemy the first?
What?
Actually, here the 5 degrees are rectangle.
No, it's ORS now. It will be inclination angle. How it will be reckoned? Its inclination angle is becoming different because you are changing your system. It is ORS now. If it is ASA, then you can say it is a backcorrect angle, but it is not right now. It is inclination angle. So if inclination angle will change, if it is ASA, they have written there, then might be the case. But right now they are mentioning ORS. See, it is ORS system. Here also they are mentioning ORS system. So it is inclination angle, and this will be your inclination angle. And if it becomes zero, that means this is like this, and
Okay.
because it is mentioning ORS, that's what it is. The angle is changed. If it is ASA, it is different. Okay. So your second question: during the cutting process, least amount of energy is consumed by natural alteration of value of, which is again the value of the value. So I previously told you the angle which matter in this power consumption will be shear angle because mostly it is a zone where actually cutting is taking place. So our main concept is machining, which is cutting a metal, removing the metal, and this is this is a zone which governs this angle governs the zone where the actual cutting or actual machining is taking place. So the power alteration or the least amount of energy consumed by nature is only on this angle. So this is the actual machining angle, and where the actual power is put. This is actual power we put here only. So the least power will be consumed. Energy means power. That amount of energy you're putting is the amount of power you need to put to the machine. So this is the shear angle or plane angle. This is the fourth question. The orthogonal cutting operation tool has a rake angle 15 degree. So we know the rake angle which is equal to 15 degree. That is just is mentioned. We know the rake angle is 15 degree and the coefficient of friction is the question is asked to you. So you know the merchant circle, merchant equation. Basically, just to divide it. It is not anything else. It will be beta by 2. Okay. This is a merchant circle, merchant equation actually. You know the rake angle and you need to find this friction angle. That's it. That's it. So it's simple. So it will be 5 which is equal to 45 plus 50 degree by 2 minus beta by 2 again. So if you calculate everything, then you know from so 5 you know that is which is 21.38 which is calculated previously. Okay. This is your 5 you have calculated in previous things. This is that 5 you have calculated previously. Same 5 you to use here, and that 5 will be treated with this 55 degree plus 50 by 2 minus beta by 2 again. If you do that simple math, beta will be equal to 52.24 degree. But what they asked the coefficient of friction. They are not asking the friction angle. Okay? They are asking the coefficient of friction. So what is coefficient of friction? Your mu is equal to that your mu is equal to tan of beta that we have, so which is equal to tan of 52.24, which is 1.291 million centimeter. Just to do, I think you can use the same phi because the chip temperature. Chip dimension. Hmm. Okay, it is mentioned from take from question number 3, so it is like this only, because in our assignment they have mentioned to take the problem 5 from this question number 3, so we can take this 5 from question number 3 as it is. Okay, this is again our next question. Orthogonal cutting process, you have to find the shear strain. Again, the shear strain directly formula you have calculate the shear strain. There is just need to find out the phi angle, because you have rake angle which is given here, and you give the uncut chip thickness, so you can find the phi. And yeah, just phi and alpha you need to find out. You can get the answer about shear strain. So it is simple formula is equal to tan of phi minus alpha plus cot phi. So you know what will be cot phi. How we get phi? You have the chip thickness ratio here, because you have chip. It is uncut chip and cut chip 0.65. So you can find the chip thickness ratio. So you can get chip thickness ratio here. So what is the chip thickness ratio? Will be R, which is T1 by T2. So your T1 is 0.30, and your cut chip thickness after deformation is 0.65. So that will be equal to 0.4615. So that phi you got R. So you have to find phi now. What is the formula for phi? From this R and phi, that you need to know, it is tan inverse of R cos, just we used previously, 1 minus R sin alpha. This is the formula, just need to put everything in that. So phi will be equal to tan inverse of this, you are 0.4615 into cos of 15 degree minus 1 minus R sin phi, it is 15 degrees. So your phi will come out 26.85. This will be your phi, and from that phi just put it here. You know, this is the phi, this is the phi. If you put there the phi will be, so if you just put the phi, so that phi will be equal to into tan of your 26.85 minus 15 plus cot of 26.85. So answer will be it is a string, so it is in a place 2.185. Okay. Just you have to find, this will be your answer. And it is a big problem, but it is very simple actually. Turning is performed on a working material with a shear strain, so it is given you got your tau. You got your tau here. You know the tau. The tau is given to you. Okay. So you need to find out your phi angle. You have to mostly go with the problem that how the problem is asked to you. So you know the tor here they are given, the shear strength that you have. I think it is not visible. Shear strength will be 250 is given to you. The cutting speed, the feed and depth of cut was it is given like V and respect to then take a rake angle is again given to be 7 degree and direction of the chip. The resulting chip thickness is 0.5. So resulting means it is T2 and using the orthogonal model approximate telling the shear force in Newton will be. You have to find Fs. Okay, you have to find Fs here. So you have to go with phi. That what will be your phi angle? Okay, that again you know phi will be tan inverse of your r cos alpha. So r cos it is your rake angle 1 minus r sin alpha. Again your rake angle. So by putting it, you know r. The resulting chip thickness ratio is given to you. This thickness ratio is nothing. It will be r which is equal to 0.5. So it is given to you. Just put here you have rake angle that is 7 degree. You can just put it there. So the phi will be equal to tan inverse of 0.5285. This phi will be equal to 27.9. Okay, just take a tan inverse. So your phi will be equal to 27.9 degree. Okay, what is your main objective is to find Fs. They are asking the shear strength. So Fs you need to find. So, uh, the shear force in the Newton will be S. You have to find Fs. Okay, so you now got a phi and you need to find the area. So you have to find area of shear plane. Okay, I think in previous question is I previously told you what you need to find out, that you need to find the tan phi. Here is a cursor. Mm, to find the tan phi which is equal to r cos alpha minus 1 minus r sin alpha. Okay, which will give you the answer like from that the phi will be equal to 29.38 as I earlier previously show you, and from you need to find the Fs which is equal to Fc cos phi minus Ft into sin phi. Okay, is equal to 1470, that you know cos of 20.38 minus 1589 to sine of 29.38. So it will equal to 789.3 Newton. So this will be a force. When you get a force, you have to find your AS, that is area. The problem was that we take the W1, W wrong. So the A is the difference of 0.1 in the answer. So it will be 8.29. This is mentioned 8.29 millimeter square. Set like here. 299 something. It can be considered 8.3 millimeter square, and just need to put this millimeter square as your S will be equal to 789.3 divided by 8.23 is equal to 5.9 megapascal. Okay, will be Newton per millimeter square. As it is megapascal, so it will be Newton per millimeter square. Okay, so this will be your answer, and this will come. Your answer will come. So we need to go over it and solve it. Right now we have to find this surface. We have to find this area of shear plane. We know the area here. Okay, so AS will be equal to this. AS is equal to, right now what we have here is AS, you know, that is WT, W that is width. So width is given Worship feature is not given, so you have D and feed. Feed is given and D is given to you, which will be AS. Okay, so it is D is equal to 0.3. So depth of it is given, so it will be width. So yeah, it will be 3. So these they are given, and that is you have F and you have D here. That is your simply width. Okay, so you what is it will be W into P1 by sine phi. So you know the phi, which is 27.5. Okay, so that 27.5, therefore it will be 0.2 into your point into 3 into 3, which is equal to divided by sine phi. Okay, so sine phi, which is even equal to 27 point, this angle you know, which is 27.7. Okay, 9. So your AS will be 1.284 millimeter per square, millimeter square, and you have to find your Fs. It is your shear force. The shear force will be equal to into this multiply, because you know what is force stress, you know it is force by area, so multiply go here. So you know that it will be 250. I mentioned previously this is answer, and this area into multiply is 1.284. So it will be again in Newton, so it will be 321 Newton, and it is your answer. It is given 321 your answer. It is given 2 pi, it is given here. Okay. So for better surface finish, what we need to do, the tool has to be sharp. It is not, because we need nose radius there. Tool, if it is sharp, you will not get a good surface finish. Rake, rake angle should be high. Okay, the feed should be large. If feed is large, it is bad. Rake angle should be low, then it will be bad. So rake angle should be large is only the correct answer. Okay. If your rake angle is large, it will have better surface finish. The rake angle should be low. It is rake angle is very low, so it will form a continuous chips. So if rate is high, so it will have continuous chip without mostly should be without build-up edge. So angle should be high is only the correct answer over here. Okay, so feed rate to be large, it only produces large surface finish. So it is only appropriate answer in this. Okay, only this. Rake angle should be relatively higher. With a low rake angle, it will be discontinuous chips, and as it will be discontinuous chips, the it will stack like this, and the bad surface will, because of discontinuous chips, the surface will have this kind of abrupt behavior. Okay, this kind of undulations it will have because of the discontinuous chips. Like if we go further, this kind of surface will form. So the rake angle should be relatively high is only the correct answer for better surface finish. Okay, so for machining performance with tool 0 rake angle and shear strain, it is asked to what is your shear strain. So you know other formula for shear strain that I already we have, that your strain will be equal to, this is your y, which is equal to tan of phi minus alpha plus cot phi. Okay, so you know you have shear plane is 45 and phi is 0. Okay, into put here 0, into put here 0, so it will be tan 45 plus cot 45. Okay, so it will be 1 1, so answer is 2. So in this case the range is only 2, it's not anywhere else. They can't provide range like 1.5 to 2.5, because it is simply 1 1 answer. Okay, plus, so it should be simply 1 1 answer. So in that case your range is only 2, it will not be like this. It will be wrong, because it's a simple chord, so it will be exact to answer. There is no should be range. You might see there is no range given for this one, because it is simply it is simply addition of two things, which is 1 1. So there is no any possibility of fraction over here, so this fraction will not be given to you. So if only answer is something, it not be, but in case it's come like 2.1001 and you write like that, will be you get minus, because it's not correct answer. Only 2 will be correct answer. There is no information that will be correct up to some decimal point or anything. It should not be, because it is 1 1 just. But if you got some answer like 1.9 or something by some mistake, you should put like that. But it is not correct because the range is only 2. There is no any range provided. Only 2 is the correct answer, because it was just addition of 1 plus 1, and 1 plus 1 in that nothing will came. Okay, so 1.9 is not, cannot be established. It is always not possible. So range is only 2. So if you got right answer 2 only, then you will get correct. If you write something like 0, 2 or like 1.95555, it is still wrong, because 2 is only, because it's just 1 1. There is no any margin of error. Okay. So which among the following is not an assumption of merchant first relationship? This is a problem that I asked you in the previous set also. Just need to focus on these things, that what are these things, that cutting edge is perpendicular to cutting velocity, this is the case. So orthogonal cutting, coefficient of friction is constant, is correct. Okay. So it's continue chip with build-up edge. Here they are writing with build-up edges. It is seems to be problematic. With build-up edge is always a problem. Build-up edge is always a problem for us. So this can't be a. So it is again some clues that build-up edge is always a problem. It is always deteriorating our surface finish, so it is always a problem for us. So this can't be an assumption. Okay, is always problem. So deformation takes place again. This is because it is also called as thin zone model. So it is also both of the Lee-Shepherd model and the Merchant's model, both are the thin zone model. They are, it is taken as thin zone as an assumption. As you mentioned, what is assumption? It is thin zone model. It is correct. Workpiece material is rigid and perfectly plastic. Yeah, it is correct, because there is no any deformation that will be considered. It is perfectly rigid. It must be perfectly rigid, and there should be not any kind of deformation is considered here. In the assumption, it will be perfectly rigid and perfectly plastic, so it will be completely plastic. There is no elasticity involved, because it need to be sheared. Okay, it is shearing on the nose. Our it is tool request, it is getting sheared here. Okay, no, this is cheap. This is cheap. It is getting sheared over here. So there is no any kind of elasticity. So it is again correct option, because it will got complex things into the picture. So it is perfectly elastic is again correct correct assumption. Tool nose radius is 0, because we are assuming it is completely sharp tool. It is again first assumption, completely sharp tool. So tool radius will be 0, because it is completely sharp tool. In assumption it is written, it is not like it is 0, but it is written that it is a sharp tool. Sharp tool means it tool radius is 0. Okay, so the implied answer is that. So only continue chip is a problem for us, and this is not assumption in merchant circle. So this is was that assignment for you, and this is also given in the solution that you have. Right now we go with the practice set 4. Okay, so this, as cutting velocity increases, the shear zone becomes, it is, they are mentioning that, I told you that what the previous small models are thin zone models, you know, thin zone models. But in reality, thin zone is not actually practice. It is zone actually. Thin zone is not there. This short zone is there, but it has something. Thin zone is not there. So how it behaved after getting the cutting velocity will increase. How it will, the shear zone will become. This thin zone, how it will become? It will be thicker or thinner or remain same or none of the above. So in the introduction, in that I think ninth lecture, the professor told it will be thinner. As the velocity will goes on increasing, the zone will be thinner, and after that will become thin zone line model, that actually assumed in the merchant circle diagram, thin zone model. So with cutting velocity increases, the thin the our shear zone will become thinner. Okay, this is your answer. As the cutting velocity increases, the shear zone becomes thinner. Okay, calculate the coefficient of friction for a natural sliding friction if the shear stress is 250 megapascal and yield stress of software model is 450 megapascal. You have to calculate this. So you know the formula. Okay, what is the formula? So mu is equal to, you know the formula. What is the formula over here? That mu is equal to tau into sigma by, because where are we right now? We are in natural sliding friction zone. Okay, so you must know these things. You are in natural sliding friction zone. So friction for natural sliding friction zone, in that case the coefficient of friction is constant and can be related to this value. Okay, so this point you must know. Okay, so this thing you must know, and by knowing this thing you can get your answer. That is mostly it is given, you have 250 divided by 450. Okay, what will be your answer? 56556. You can take, which is actually 0.5556, so it is like that. It's a recurring format, so it is the correct answer. So this is your correct answer, that is 0.556 is the correct answer. I show you because it is in natural sliding friction region, so where your mu can be related to tau divided by 6y. Okay, calculate the friction angle in degrees using Zoref's model. If mean normal stress on the tool face is 450 megapascal and the value of constant K is 300 megapascal. So we know what is the Zoref's model. So this will be your friction angle, and from Zoref's model it will be tan inverse of K by sigma average. Okay. So what is your sigma average? It is given 450 megapascal. Okay, here it is given here, that is 450 megapascal is given over here, and the constant is given 300 megapascal. So it is simple. So it will be tan inverse of okay, tan inverse of what is your this K, 300 divided by 450. So is equal to find out. So is equal to 33.69 degrees. This will be your answer. Okay, for calculate the friction angle. Okay, this is your answer. You have to find out the friction angle. This is your answer. How to? Okay, I told you what is the friction angle. If the working rake angle decreases, then the friction angle will. Okay, it again it will decrease. Okay, it is given the formula that we also know the formula, that is normal stress will decrease, due to which the normal stress will decrease, your sigma average will decrease, and due to which your beta will increase. First, your sigma average, this will decrease. Yeah, this will decrease, due to which your beta friction angle will increase. Yeah, friction angle will decrease actually. This beta will going to be decrease. No, with decreasing rake angle, your this will increase. Your sigma average with increasing, with decreasing the rake angle, your sigma average start increasing, because it become like this. This is your tool. This is your rake angle. As your rake angle start decreasing, the normal force acting on this will start increasing. Due to that normal force start increasing, your sigma average will start increasing, because see, this is normal force, and it will start increasing. So what is your normal force here? This will be resolved like this, and this will be like this. Your friction force and normal force. Okay, this will be some resultant here, and this will be co-linear with your other forces. So when this will increase, your sigma average will increase. And as sigma average will increase, you are according to this formula, your friction angle will decrease. Okay, so this will be the concept. If it will decrease, your correct answer is decrease. Okay, so this is the correct answer, decrease. The measuring process demonstrated in the figure is below is. So this is a which process is this? So they are asking simply which process is this? So this is sawing process. Okay, you know this is a sawing process. Okay, this is a sawing process, you know. Okay, it is mentioned here that it is a sawing process. This is your next problem. Here we have to find out, given the tool, what you have to find out the width of the chip and uncut chip thickness in millimeter if the cut is 0.5. Okay, depth of cut is 0.5 and the field is 1.5 per revolution. So you have D 0.5 and your F is 1.5 and you have phi s is 75 degrees. Okay, this you have. Okay, so wanted to find out now. Question is 6. Okay, what to find out now. Uh, Given the tool to calculate the width of the chip. Okay, need to find the width of the chip. So which is the width of the chip? So width of the chip will be your width of the chip will be, you know the formula, it is, so it is equal to D by cos of phi s. Okay, and again you need to find out T1 is equal to uncut chip thickness F cos of phi s. Okay, so just put the values. Your W will be equal to 0.5 divided by cos of phi s will be 75 degree, which is equal to 1.93 millimeters. Okay, and what is your F? You have to find out the T1. Okay, you have to find out the T1. So what is your T1? You know the formula over here. Okay, you have this formula over here. So this is your T1. So this is your T1 formula. So T1 will be equal to F field is given, that is 1.5. So it will be 1.5 into cos of phi s is again given to you, this is 75 degree. So cos of 75. Okay, so it will be equal to 1.5 into cos, it is mentioned, so it will be 0.388 millimeters. Okay, so answer will be 1.93 and 3.88 millimeters. Okay, it is answer 1.93 and 3.88 millimeters. Those are correct answer. Okay, right now what we have, calculate the uncut chip thickness. We know on T if the depth of cut is given to you. Depth of cut is 0.5. Okay, what is this in millimeters? Width of cut is W is equal to 0.8 millimeters. Okay, and the feet per revolution is given 1. So we know the formula. Okay, it is given in that slide. F into D is equal to W into P1. Okay, this is the formula. In simply get, you know the formula, like you know the previous formula that just written for calculating the width and the thickness, uncut chip thickness or the ratio. Uncut chip thickness, you know, the W is equal to D cos phi, and your thickness is equal to this keyword uncut chip thickness cos phi. Okay, just multiply this. It will be equal to W into this is just equal to W into T1, which is equal to D into D cos phi s into F cos phi. It will be cancelled out, so it will be D into F into D. Okay, this is your formula. What you need to find out T1. You know have F. You have F, which is 1 millimeter per revolution. Okay, it is mentioned in the formula that it will be 1 millimeter per revolution. So your F will be equal to 1. Your D is equal to 0.5, and your omega, sorry, not omega, your width is equal to 0.8 millimeters. Not millimeters, it is just millimeter. You know. 0.8 into T. What is your T? You have to find out. So just multiply. You know T. Your T, you know. Okay, this is the T1 that you just need to go. Be 0.5 divided by 0.8, and your answer will be 0.625. This will be your answer. Okay, 0.625 is your answer. It is mentioned here 0.625 is your answer. Okay. So again you have to calculate the slightly difficult problems now. But you have to calculate the specific energy required to remove a unit volume of material. Okay, UC you need to find out. UC material joules per millimeter cube if the cutting force is given. So what you are given? You need to give an FC. You got FC here, which is 500. Okay, for diameter is 30 and RPM is Rn is equal to 300 RPM. Okay, the feed is 1.2 millimeter per revolution millimeter, and the depth of cut which is given, depth of cut is 0.5 millimeter. So we have to find out MRR first. You know what is your FC? So we have to find out power. Na? What is your power? You see into MRR. Okay, and you MRR you know. And what is again power is? Same power is equal to FC into VC. Okay, you have FC here. You can calculate the VC, and by this you can calculate. You can also calculate MRR, FC, VC. From that you can calculate the VC. Okay, this is your should be your criteria how to solve it. So you need to first find out your MRR. So what is your MRR here? Okay, you have to find out MRR. What is your MRR? You know MRR is equal to FT pi Tn by 60. Okay, so your F you have 1.2 into D, D is 0.5, whatever, zero point 0.5 into pi to D is 30 into N, it is in RPM 300. Okay, you have to put in RPM, okay, because you have to get divided by 60 always. So will be in seconds. So MRR will be in some seconds, millimeter cube per seconds. Okay, so your MRR will be, you have to find it out here. Yeah, MRR is 282.743 millimeter cube per second. Okay, you have now FC MRR. Okay, so and also from this, what is this actually in this equation? What you have calculated here actually, this pi x is actually your VC. Which is your VC is equal to, just calculate it, 471.223. Okay, 470.223. This is your VC. Okay, so what is your VC? Is the same area. So it is the answer is given. So your VC is 471.223 is velocity, so millimeter per second. Okay, so you can calculate the power now. So power which is equal to FC PC into FC or FCVC, that is not in the case, into FCVC into what is this? You have to your force, cutting force is given, this is 500. Okay, so the answer power will be 235,611.5, as it is we can calculate it into seconds. Okay, so it will be directly in watt. You can consider, because the shaft is big, 30 millimeter diameter shaft, the feed is high, the force is high. So in that case, your machine maybe some large lathe machine is there, and due to that large lathe machine, this might be the power may go up to this value because it is very large. So 30 millimeter diameter is very high. You can know 30 millimeter diameter is high. So due to that, your cutting force is high. Due to this power can come. So this is just an example, and this problem might become because of the numerical data. Because you know the diameter is large, so it is not done on normal length. So you have a big length, and large length will be required because it is 30 millimeter of diameter, so will be very high. Mass will be high, density will be high, power required to rotate it will be high. So okay, so cutting force, anything will, it can go very high. Okay, so your energy will be high, so you need duplicate because your rotation is also high, so definitely need a lubricant over here. So, and this problem is checked it, so problem is not have any problem. So this kind of problems we have asked you, where the things not hypothetical, but like you never go through that problem first, and it can be there. So formula, I think formula is correct. So it can be possible in large millets this force can go because it is something high. Okay, it will be 235 some kilowatt it will be there. This can be happen. So problem is actually correct. There is no problem, issue with the problem. So you know the power you got. What is the same power? That same power is equal to your UC. No, your UC. Your UC into MRR. So what is your UC? You have to calculate. You know power. You have this power. So just to get UC, you have to divide this power by MRR. Okay. So what is your power? It is 235,611.5 divided by your MRR calculated is equal to 282. Okay. So just I'm putting one value 282. Can put actual value 282 into 7433. Your answer will be 833.3053. Okay, and the unit is mentioned joules per millimeter cube. Okay, due to some large I told you large everything it is this might become okay. So your UC got answer is here 43.3 got answer. Okay, so calculate the specific energy required to remove 1 millimeter of concrete chip thickness if cutting force is 500. Everything else is same over here. Okay, you can check everything else is kept same. So you have UC already. Okay, so you have UC over here which is equal to 833.3053. Okay, how we get this from where from you get this? Obviously from question number 8. Okay, we got this answer. Okay, so and this is just same. Okay, we is equivalent to same to question 9. Okay, so we get Q8 and you know the formula that UC is equal to U0 into T1 of 0.4. So you need to find T1 now. So how you can find T1? You have this angle, that is tool with side edge catching angle. Okay, you have phi s you have right now. Okay, yeah, it's phi s something. So what it is, how it is actually pronounced? It's not just y, so some phi s. Phi s you have over here. Okay, yeah, phi s you have which is equal to 78 degree. Okay, so we need to find out t. So what is the formula for t? You already discussed. Okay, t which is equal to cos of rs, you know, into feed. You have feed, yes, you have feed. Okay, this is feed is you mentioned earlier. So you have feed, yes, you have feed, and you have cos phi. So you can find out t easily. So t1 which is equal to 1.2 into cos of 78. 78 degree. Okay, this is wrong. So it will be equal to 0.25. This will be a thickness. Okay. So from this thickness, what you can find out, which is equal to 0.2494. It can be equated to this value. Okay. 0. What is 2494? Okay. So this is what you can have. Okay. So this is what you have. So you need to find out right now. Again, what you need to find out? 1 millimeter. So it will be UO. You need to find out. So you know the formula. What is the formula? You know the UC is equal to UO into T into minus 4. So that is written previously. So right now you have T. Okay. You have U, C and T. So what find out this? This is again very simple concept right now because we are finding everything. We calculated the things first. So it will be u0 which is equal to 833, which is came from the previous question, it is 8 number question, divided by your thickness. So what is your thickness? So 0.2494 into, it is important, minus 0.4. Okay, it will be divided getting a 4. Okay, so this is minus sign is important. If you wrongly take minus sign, the answer is wrong. Okay, here the 0.4 minus answer, minus point is important. Okay, minus sign is important. So we get u is equal to 478.1484 joule per meter square, because simply it is in, what is written, in joule per millimeter cube. What you are actually doing here, you are just multiplying by a millimeter. Okay, because this will came above, because it is minus, I told you, because we to check the sign. Okay, as this is minus, it will come above. Okay, as this is minus, it will come above, so it will multiply, so this your 1m will be get cancelled, it will convert into square. This is your answer. Okay, so it will be as mentioned here 47, so it will be mentioned here, that is 478.1484 joule per millimeter square. Okay, this will be your answer. Okay, we mentioned, so go to first question number. We don't have time. I don't have time. I have many questions, we don't have time. So just go slightly fast. Calculate the feed force and radial force if thrust force is 300 and the tool has sided cutting angle. So you have to find FR and FT. Okay, you know FR and field force, you know FT. Okay, so again slightly simple question. Okay, because you know FR is equal to FT sin phi s. Okay, and your F is equal to Ft into what, cos phi s. It's simple, isn't it? This is simple thing that you know, and you know phi t. Okay, you know this phi t. Suppose you know, and you know this phi s. So just what you need to find, you need to find Fr, heat force, just 300 into sine of 80 equal to 295.488. Okay, so what will be 295 point, oh, point 4422 Newton. Okay, and your Ff will be, what is it, uh, 300 into cos of 80. Okay, so what it will be, 52,094 Newton. So what they asked you, field force first, then radial force. So just it will be 52. This will be the answer, because they are asking field force first. That's just way answering it that way. There is no rocket science involved here. So we are going to question number 11. Calculate the number of revolution per pass valves going into time. Okay, right now we go with forces. We go with right now time. So we have L. Just write down everything that we have. The length of the cylinder, we know it is 80 millimeter. The spindle speed is R, which is equal to 250 rpm. Rotations per minute. The field is equal to 1.5. Okay, F field is equal to 1.5, and passes N is equal to 4. Okay, what you need to find out, calculate the number of revolution per part. You just need to know the formula. Okay, so the number of the number of revolution per pass. So what need to find out, the number n. Okay. Wanted to find out number of revolution per pass. You know the formula will be L by F. So what is your L? 80 divided by F 1.5 equal to 53.333. Okay, number of revolutions per pass. So it will be 54 revolutions per pass. Okay, the L is 80, the feed is 1.5. Okay, that's why. Okay, L by 5 is a simple answer. The time per pass. This is number of time per pass, number of revolution per pass. Now find the time per pass. Okay, time per pass is equal to, you know the formula. Okay, will be L divided by F into N. N is in RPM, so it will be in minute. You have to convert into seconds. That's it. So 8 into 60, because you need to convert into seconds. You have F 1.5, okay, into N. Your N is 250. This 60 we are using because you have to convert it into seconds. Okay, this is because convert into seconds. This is in a minute. Okay, this is in a minute. And it will be converted into seconds. This will be 60. So this answer will come 12.8 seconds. Okay, so this will be, here you have a first answer 53.33, 12.883 seconds. Seconds. Okay, this seconds. Second. Okay, this is second. You got those answers. Right now we have to find the total time. So what is the formula for total time? Just multiply with number of passes. You have for one pass, you have 4 passes here. Just multiply this 12.8 into 4, which is equal to 51.2 seconds. Okay, the actual formula will be total time. It is LFN. Okay, into what? N. So n, you have number of passes, so you can just put these values. You know it is 80 divided by 1.5. Then is RPM, so multiply by 60 to multiply by 250 is RPM, and into 4. Just multiply into 4, it will give you the same answer, 51.2 seconds. This will be your answer. Okay, this is correct. Now we are going to shaping operation. Okay, so shaping operation, you need to find the thrust force is given to you. Calculate the feed force and normal force. So again it is just cos phi. You need to know the formula. F is equal to ft into, what is it, cos of phi s. No, it's alpha phi s, y s of phi s. This is not phi s, delta s. No. Yes, y, that is shear, side cutting shear side. Oh, this primary principal cutting is angle phi s. Size r is gamma is gamma s. It's gamma s. Okay, so gamma s is correct here because it is gamma. 2 alpha is gamma. Okay, sine gamma s. This is your concept. So fn ff into fn, so it will be ft cos phi into, you know, feed force and normal force to calculate. Simple, you have 250 Newton into cos of a 65 degree. Okay, so it will become 105.654 Newton. Okay, this is again correct. And 250 into your sine of 65. Okay, so it will be 225 22.576 Newton. Okay, so this will be your answer. Okay, this is the 5-year answer that I already mentioned is correct. Just need to take multiply with sine phi cos phi. That's it. That's your answer. Then to find out normal force and feed force in shaping machine. Okay, operation. So again we are going with shaping operation, but slightly complex. Calculate the specific energy, that is to remove the uncut cut chip thickness. Okay, 1 millimeter of uncut chip thickness. That is what we need to find out actually. UC or U0. It's U0. Okay. UC will be volume. You have to find U0. Okay. This is U0. It is asking. So it is like exactly the same, but in this case you have VC is given to you. Okay. What properties you have, you could check. Okay. You have VC is equal to 0.5 meter per second. You have your gamma s is equal to 750 degree. Okay. You have P 1500. You have F, which is 1.5, and D 0.8. Okay. So, and power is again given. The power is equal to, okay. Power is in watt. Okay. Means joule per second. How to find, okay. I have to go with MRR, because MRR you have to mostly you have to find MRR and get answer the power how it will be. So you know it will be FT into VC. Okay. So you know F you have 1.5 to 0.8 into VC will be 0.5 into 100,000. Okay, because it is 0.5 meters. You have to find in millimeters. Okay, this is velocity, so you do meter per second. So your answer directly come into 600 millimeter cube per second. Will be your MRR. So we know what is your power. Power is equal to UC into MRR. You know the power is, okay. What is your power? 500 watt. It is given. So you need to find UC. What is your UC? Okay, just P you have, power you have 1500 divided by, what is your MRR? 600. Okay, this MRR, this MRR what you have. Okay, here you have this MRR. This MRR will be go or down. Okay, here. So your VC will be this power by MRR. Okay, and what it is? It's calculated 2.5 joule per, this is millimeter cube. Okay, your UC you got. Now you got UC. What you need to find out? Because you need to find out UO, not UC. They are asking for UO. Okay, this is asking for UO. UO they are asking for, not they are asking for UC. You calculate UC now. Now to go to UO, and you know what is the formula for UO. Okay, it's again simple. So you know UC is equal to UO into T raised to minus 0.4. So you want to find P now. So you know, again simple F cos of gamma s you have, it is 75 degree. You know, due to 1.5 into gamma s will be cos of 75, which is again equal to 0. As you calculated 38822. So right now what we have, you want UC. Okay, and what we have, you want UC, and what you have this and this. Okay, calculate it now. So it will be 2.5 into what is this? You have to find out into T. You know 0 point is millimeters. 0.3882 millimeters raised to 0.4. Again, check the sign. Minus sign is there. Okay, it's again important. The sign is minus. I told you previously also. The minus sign is important over here because it will go up. Okay, as minus sign is there, so it will be multiplied instead of getting divided. Okay, so you will have your UA, which is get divided over there, so it will be multiplied actually, you know. So it will be 1.7118 joules per millimeter square. Okay, because you are calculating U0. Okay, per 1 millimeter of cut sheet thick. Okay, this is your answer. Just multiply. Okay, because why multiply, you know why multiply. I'm trying to multiply. Okay, so your this your u 0 will be equal to 2.5 into 0.38822 to 0.4. But when you multiply, what will happen? This minus sign will go off. Okay, so just write here, this is because there is no space, into 0.38821 0.4. Okay, this will be you to calculate, and these calculations will lead to this answer, which is correct answer. Okay, we go for next problem now. In shaping operation, again we are focusing on shaping only here. Approach length is 10 millimeter. Average cutting velocity is 25 millisecond. Meter per second is given. Mention, check units, meter per second. Feed in gate also. In gate also mostly the units are changed. You have to be cautious about units. So average cutting velocity is 0.25. It is mentioned what is the shaping, so with the approach and all that stuff. It's 10 millimeter. Velocity is 0.25 meter per second. Feed per stroke. Feed is equal to 0.75 millimeters. Okay, per stroke it is given. Quick return ratio R is given 2. For our piece of length is given, L is given to you, which is 500 millimeter, and P is given to you, is 25 millimeter. Okay, so time for forward motion you have to find out. Okay, time for forward motion, okay, is equal to, you have the formula, equal to L plus 2 into L divided by your V. Okay, what is your L? 500 plus 2 into 10 your approach length by 0.5 into 10 is to 3y, because it is in millimeters, not in millimeters, in meters. Convert it into millimeters. Okay, it will be 2.08 seconds. Okay, this is your answer. And on backward motion, okay, you have to calculate time for backward motion also. So how you know you have quick return ratio we have, so you know for time for backward motion now. So it is again you need to calculate time for backward motion is equal to TF by R is equal to, what is the TF? 0.28 divided by 2. So it will be 1.04 seconds. Okay, this will be your answer. This will be your answer. Okay. Okay. In shaping operation, again approach length is 10. I think we kept everything same over here. Just to change, calculate the total time per stroke and total number of strokes to cover the surface. Okay, and total time. So to change some additional parameters, you add, everything else is same. Okay, that is the concept. So we need to find total time now. Total time, we need to have a formula. Total time per stroke. Okay, total time per stroke is written. Formula is L plus 2L by V into 1 plus 1 by R. Okay, so it will be 500 plus 20, as you know everything is same, 2 into 10 20, 0.25 into 100,000, because it is in millimeters. You will take, and this is in meters. Okay, to match the units, simple. Okay, into 1 plus 1 by 2, so it will be 1.15. You know this 1.15 1.5, so it will be 1.15, 1.5, 1.5. Okay, so it simply will be equal to 520 by 250, yes, right, into 1.5 is equal to 3.2 seconds. This will be your final answer. Okay, this will be your final answer. Okay, 6.12. And now total number of strokes to cover the surface. For you to find out total number of strokes to cover the surface, you have to find out total number of, so here just have to add 100. Okay, is not kept, because you have to find the total number of, what you have to find out this total number of strokes to cover the surface is also going to find out. Now that is not mentioned, it is 100, which is very simple. We calculated what total time per stroke we have. Total time per stroke, which is equal to total time required for stroke is 3.1 3.12 we have seconds. Okay, so this you know. Now number of total number of strokes required to cover this. So what is this? Total number of strokes to cover the surface. So what it will be? Formula is B by F. So you have the B, this 75 divided by F 0.75 will be 100. Okay, and that 100 you need to multiply. Okay, because you can see that formula, just need to multiply that 100, okay, with B, because if you to multiply the formula of total time per stroke, we have into P by F, which is number of strokes to cover. So multiply by 100, these need to multiply with this, and the answer will be this. Okay, it is fairly simple. Okay, let me write down the formula for you. Okay, so here will be formula for total time. What we want? Total time we want. Total time, which is equal to 2 plus 12 divided by F B B, here it will be bracket BF. BF is your this. Okay, I told you just multiply with 100. How you are multiplying with 100? Because you are just multiplying with this term. So this is will be B into F will coming here, and your entire one thing will be same. Okay, so it will be 3.5 again. This answer will give you 3.25, 3.12, and this will give you 100. So just multiply. So your final answer for total time. Just doing this, final answer for total time will be 100 into 3 point, because it is BF first. Okay, just we are multiplying by term B into F, you just get the term B into F. Okay, here we have the term B. Just you can check the formula from slides. It will be into F the slide. It is 100 into 3.2. Okay, 3.2 is equal to 312 seconds. This will be your final answer. Okay, in seconds. So mechanism using shaping operation is pulley and cross belt mechanism. This mechanism is not used, you know. This is used in shaping or planing. Okay, this is there is a further question on this. This is used for planing. Okay, this mechanism. Whitworth Quick-Return mechanism is correct answer, because it is used for shaping. This will be a correct answer. And this Geneva mechanism is not used, so this will be a correct answer. Okay, Whitworth Quick-Return mechanism is a correct answer for shaping. Okay, for shaping. So for planing process is used for which, for the machining of, it is used for very large, like the professor is told, because it is very large. It is used for large workpieces, and there the mechanism is cross pulley. Okay, I mentioned you the cross pulley belt mechanism which is used for planing operation. Okay, and this pulley and cross belt mechanism, and this it is used for the planing process is used for the planing process is used for machining of this. Okay, very big part like ship. It's very big part is used by using planing, and there we have to use different mechanism. The bull here will be very high if you use the pivot to return mechanism. So you can't use that mechanism. So we have to go different mechanism, and each it is come different mechanism. And planing is again a very rare process. You mentioned there it is kindly rare process used for big parts. Okay, used for machining of big parts. This is for machining of big parts. Okay, like very big parts like ship. Okay, and this is rare also. So this answer. Usually reaming operation is performed after drilling operation too. Okay, this is the correct answer. Okay, increase the surface finish. This is again dilemma. See, surface roughness is different, surface finish is different. Increasing surface roughness means you are increasing the asperities. Okay, this form you are increasing. Okay, increasing surface roughness you are, and increasing surface finish means you are doing this. So both have different meaning, but concept not to confuse. Okay, so this is surface finish where you are increasing the finishing, and increasing the surface roughness means these asperities you are increasing. So it is not considered, never considered to increase the surface roughness. Okay, decrease the hole inside, increase are not a concept. So increase the surface finish only we are using this, because there is a lot of vibration involved. Okay, there is a vibrations involved while drilling. Okay, vibrations are involved in drilling. Okay, vibrations are involved in drilling. Yeah. Drilling operation. To reduce these vibrations, yeah, due to which the surface finish is bad, and to increase the surface finish we are using reaming operation. Okay, this is to perform. After this everything we will go with, after everything like this thing we go with reaming operation. Okay, yeah, we will go with reaming operation. This is your correct answer. It is mentioned increasing surface finish. So right now we go to 18th problem. So what is your 18th problem? We have time. Yes, we have time. A 12 millimeter hole to be drilled. So you have to understand first of all, this is a drilling process. Okay, which is mentioned drill. You have to apply a formula for drilling now. Okay, with RPM 800 rotations of the drill. Calculate the power watt if a feed is 0.8 and the specific energy consumed is 2. So you know UC 2. What to find out P. So we know what is P. UC into MRR. That's it. What do you have to find out? MRR. Once you found MRR, your answer is correct. It's going. You will get answer. Okay. What is MRR now? You know in the formula n by 60 f. This is your velocity, feed velocity actually. This you have. What you to find out MRR is. What is it? N. What is your N? Your 800, which is RPM to 60, and this will be in meter, millimeter cube per minute. Okay, this you need to know. It is mentioned in the slides also. This is in millimeter cube per minute. Okay, you need to understand these things. You need to remember these things. Okay, in reading it is different. Okay, understand these things. It is different in milli. So your feed will be 0.8 into pi by 4. It is your into d. What is your d? It is mentioned 12. Okay, 12. of this. Okay, this is not a square of this. Okay, square of just this. Okay, so it will be 1206.37, okay, millimeter cube per minute. Okay, you have to understand this. This is minute. You have to combine it because if you want answer in watt. What is problem in watt? What is watt? Watt is joules per second. What is this in minute? You have to convert it into seconds. So what do we do? Okay, we have a minute. It will be 20 per minute. So how many per seconds? We just calculate. Just divide by 60. Okay, so it will be 1206 divided by 60 is equal to, because it is millimeter and 1 millimeter will take 60 seconds. So divide by 60 will get in 6 per second. Okay, in drilling you have to see these things. Okay, to be assured with these things. So your power will be equal to UC into MRR. Okay, it is given 2 into 20 is 40 watt is joule per second. Okay, okay, this is 40 watt is your answer. Okay, this is a problem. Okay, right now what we need to find out, thrust force and torque. We have given a point angle. So you know point angle, this is drill bit, consider. So your this angle. Okay, so this is drill bit, this angle is your point angle. Okay, you know this is a point angle. Okay, this is your point angle. We have to check for what is a point angle. This is your point angle. But what is our beta? Maybe half of this only, you know. So we have to take 120 divided by 2 will be your beta. Okay, will be 60. Simple. Okay, you have to see these things, and you know rest of the things which is already mentioned over here. What are the rest of the things mentioned over here? You have D 40 millimeter. You have RPM 500. You have thrust. No, don't have thrust. Plus your angle. So your beta will be, as I mentioned, 60 degree. Okay, you have to go check this. You have to go this here. Okay, this is what you have here. 60, and you have applied force. F is equal to 500 Newton. The cutting force FC is 350 Newton. Okay, and further calculate uncut chip thickness and width of the chip if the feed is 0.95. The feed also given per revolution, which is 0.95 millimeter per revolution, is again given to you. Okay, so it is mostly based on formulas. Okay, so we know what is your F. Your F is equal to 2ft sine theta. To find thrust force Ft, so it will be F by 2 2 sine theta. Okay, will be Ft. You have to find out Ft. So your Ft will be equal to 500 divided, this relation 500 divided by 2 into sine of 60 degree. Okay, will be Ft. So Ft is equal to 288.675 Newton. You got your Ft. Okay, this is your Ft. You got Ft, thrust force you got. Now we want Fc. Cutting force. But the cutting force is also given. Right now what to talk? Fc you have to calculate torque. So here is the Fc, it is given. Mentioned here Fc is given to you. So you have to find out the torque now in Newton per millimeter. Okay. Torque, what is the formula for torque? It is very simple. Just your Fc into d by 2. So it will be equal to Fc. What is the Fc? The 15 which is mentioned into d by 2. 40 by 2 will be 7. So it will be 2450 Newton millimeter. It is torque. Okay, Newton millimeter. Okay. What is this? Is torque. It is mentioned over here. It is a torque and recording. Check. Okay. It is a torque and what you need to find out the next is T1. You got your torque which is mentioned here. You have to find the T1. What is the formula for that? F by 2 sine beta. So you have your field which is 1.95 into divided by 2 into sine of beta. What is your beta? Sine of 60 degree. Okay. So it will be 0. Which is mentioned 4136 millimeter. Next you have to find out your width. Formula for width is d by 2 divided by sine of, it's going down, so let it go, d by 2, let's change the color, okay, okay, d by 2 divided by sine of b, okay, with d by 2 by sine of beta, so which is equal to what is the d by 2? 40 by 2 into sine of 60 degree, which is equal to 8.0829 millimeter, which is mentioned above. Okay, so you got every answer over here. You got every answer over here. Okay, here we are going with slab milling now. Slab milling operation, you have to find a T average in millimeters. It is problem in this question, is in assignment actually, but simpler version. So we have D. It needs to be capital D. Okay, it is slab milling now. You have field. Your depth of cut, because water slab I told you small because you have D here, okay, and you have D here. Depth of cut is also now, so will be 1.5 into millimeter per tooth something. Okay, no, this is not depth of cut, this is cut, so it will be D, depth of cut. Okay, so what you need to find right now, you know, T average is equal to 1/2 of T1 max. So what is T1 max? We will calculate now. T1 max is equal to this formula, F under root 2D by R, which is equal to 0.3 into 2. You have D is equal to 1.5. Okay, you have D 1.5 into this R is 25 because diameter is mentioned, that's why you have to take R. Okay, it is complete square root. Okay, just don't do anything, it's complete square root. Okay, whatever, it is complete square root. Okay, don't do anything, it's complete square root. Okay, so it will be 0.1039 millimeter. So we know this is, we got T max. Okay, what we got here, we got T max here. So this into 10 to this formula. Okay, to send this to this formula, which is T average is equal to 1 by 2 T max. So what will be your T max? So what will be your T max you have? We just write, go somewhere else. So what is your T max? Is this? You just put this here and mostly what you have to do is divide by 2. Okay. So what that answer will be? So which is equal to your T average is equal to 1 by 2 into 0.1039 is equal to 0.0519 millimeters, which is the answer we got. Okay, this is T average. This is the answer we got for T average. Okay, so what to do? Yeah, so is correct. Okay, check. The correct answer is 96. You can put 96. Not done. Okay, this is millimeter. So 21 in the slab milling operation is performed with diameter milling cutter diameter, the with a diameter with a milling cutter of 45 diameter, so diameter is 45 millimeters, and the depth of cut T is 2 millimeters, and the feed velocity is taken as what is it, feet per second. It is it's 1.3, feed velocity is 1.3. Okay, millimeter per second, and the width is 10 meter, and you have specific energy of consumption. So you see you have calculate the power, so we need to find MRR. Okay, what you need to find MRR first? MRR need to find out, and just multiply power is equal to your what, MRR into this UC. Okay, the UC, that's it. So your MRR is, what is your MRR? Simply it's B actually, but you can put B into D into BF. So check what a mistake we did. This BF, so you can check it is per second, isn't it? So how can we feel it is velocity. Today I'm also slightly tired. So feed, it is feed velocity. Okay, the feed velocity, and this is not a field, this is feed velocity. So VDF is feed velocity. So VD, which is equal to what is your P, 10 into D, which is equal to depth of cut. So that is 2, and your VF 1.3. Okay, which is equal to 26. This is some simple 26 millimeter cube per second. And what we need to calculate? What we need to calculate? Power. What we need to do? Just multiply. That's it. Okay, you have to multiply it with something. With UC. So what is your UC? 3.5. So power is equal to MRR into UC. So what is your MRR? 26 into UC is 3.5. So your answer will be 91 watt. Okay. Answer asking watt. Okay. This is your watt. 91 watt is your answer. Okay. Let's go. So again, the last problem we have here. Slab milling operation is performed with a milling cutter of 65 meter diameter and 12 meter width. The RPM rotation. If feed velocity is 1.5 millimeter per second, calculate the feed per tooth in millimeters. So what is the formula? What is the formula? Simply UF, which is your feed velocity, divided by N, your RPM, which is your Z, which is your number of teeth. You have UF, it is given. We have number of RPM, and you can see here the shaft is also given. So this will be your unnecessary data. So just to confuse you, okay? Just to confuse the reader, what they have put, okay? Just to confuse you guys, it is put. There is no meaning. So we have PF, it is 1.5. Okay, we have 550 because it is millimeter per second, and RPM means other different things. So what we need to do? Multiply by 60 over here, and your number is 12. Okay, So your answer is 0.0366 millimeter. Feed. Okay, this is your feed. Okay, feed per tooth. Feed per tooth. Okay, this is your feed per tooth. This is your feed per tooth. You have to find out. So this will be your feed per tooth. Okay. Okay, this is your answer. Feed per tooth. Okay, this is simple formula you have to use and calculate the answer. Shit. This is where this is RPM. This is number of teeth. Okay. So this is your answer 0.0036. So right now we have some more problems in why thin wire strain gauges are not used in practice nowadays. You told that it is very thin. It is very thin. So what will happen? It is very difficult to detect any damage in it. Okay, this is the correct answer. Okay, it is detected damage because it is very thin. So we can't take a damage it is even present or there because of the thinness. As it is thin, you can get if there is any damage. And again, unable to generate correct result as high temperature because of at high temperature. If there is a high temperature condition, it will deform due to temperature also. Okay, deformation is maybe due to temperature. Okay, you know this fact. Deformation maybe due to temperature. Okay, that you need to find. No. So this is again correct. Okay, why you are not using is we are answering. Okay, this is also correct. So what we have the option for this, both of the correct and none of the above. So this is wrong. This was wrong because both of these are correct. This is also correct. This is also correct. So both of the correct is your correct option. Okay, this is your correct option. Okay, both of them. This is also correct. This is also correct. So which elements are used as a strain gauges? This tension is mentioned in the slides. First you are using thin wires. Now you are using piezo element, piezoelectric elements. Okay, this mentioned piezo elements. Okay, carbide, silicon are just meaningless terms. Piezoelectric is correct answer. Okay, because of this property of the expand direct effect, indirect effect, you know. Electric. Again, direct effect of piezoelectric element is used in mechanical systems. What is the direct effect again? If we apply a force, okay, this is a plus, minus. If we apply a force, the voltage will be generated here. Okay, the V will be generated. So it will be not vibrator, not a damper. It is not even energy device. It is a transducer to measure force. This is F. Okay, so we can measure the force. It is directly proportional to voltage V out. Okay, this is your V out. Okay, so it will be act as a transducer. Okay, to measure the force. Mostly sensor to measure the force. Okay, as mentioned is a direct effect. Okay, what we need to calculate direct effect. Okay, but test effect is direct effect. Okay, we mentioned transducer. Okay, vibration generation is which effect of neurotech element. So direct effect you know. Now you need to find the indirect effect. So we provide, you have battery over here, you have plus, minus, provide a battery now. So what do? You have a battery and you provide current over here. What will happen? Now this will expand. Okay, why? Vibrate. So it will expand against depending upon the frequency of your current. Okay, AC, if you are providing AC, depending upon the frequency of current, it will vibrate. So it will vibrate with this position, or this mostly from this position, mostly to this position it will vibrate. So due to this vibration, it will create, this is actually indirect effect. So this is the correct answer. Direct effect you know, I told already, which is the transducer. Here you are getting a vibration in this side. Okay, you are getting a vibration. So it is called as vibrator. So which effect is this? This is a indirect effect. Okay, it is mentioned in the slides clearly. It is an indirect effect. Okay, so indirect effect would be a correct answer. Okay, so calculate the shear plane angle. This is the problem that we actually have in our previous session. We not able to complete. So here we are completing it. Okay, let's complete it. Have slightly more time. So calculate a shear plane angle using slip field theory. Okay, so by slip field theory, what you have 2 phi plus this is a friction angle phi minus 2 alpha is equal to pi by 2. Okay, this will be your which theory? Slip line field theory. According to slip line field theory. Okay, like Lee and Shepherd equation. Okay, according to slip line field theory. Okay, this will be your equation. So you have coefficient of friction, so you can find this beta. Okay, beta equal to tan inverse of mu. So beta, which is alpha, which is equal to tan inverse of 0.58, which is 13.11. So just put into the formula 13.11. So this I have to take that 5 out. Okay, what I did, just take the 2 common and take it out. Okay, so what will be my equation will be pi plus minus alpha is equal to pi by 4, which is 45 degree. Okay, so this is my equation now. Okay, so this will be, so phi will be equal to 45 minus 22.11. Phi is 22.89 degree. Okay, this is approximately equal to 23. Okay, so this is what 22.89, which is approximately equal to. Okay, so this is slightly big problem, but it is, you can solve it. Okay, so what you have over here, it is slightly big problem, slightly big problem. Okay, slightly big problem. So what we do, we just add a blank slide. Okay, here to get complete concept. Okay, so what do you have? There's an important concept, that what do you have? It is already 7 we crossed. Just wait for, it is just one problem left. Okay, just one problem left. And two problems are there, but both of them are connected to each other. This is actually one only. So what things we have? We have alpha, which is this 12 degree. Okay, oh, we don't have written. Okay, yeah. So we have alpha written ASA. Okay, so alpha we have 12 degree written ASA. Okay. We have D is the depth of cut, 0.75 millimeter. We have uncut thickness T1, 0.38 millimeter. Now you have friction, coefficient of friction, which is mu 65. Shear stress of the product material is given. Okay, 580 megapascal. Okay, we have to what find out? We have to find out F cutting and F thrust. Okay, so we start with Merchant's equation. What is that? 2 phi to phi. Let's start with my third equation. We need to find out phi. Okay, 2 phi plus this is beta actually plus alpha is equal to 90 degree. So we have phi which is equal to 90 minus 33, because how we got 33? U is 0.65. Okay, so your beta, that is equal to tan inverse of 65. Okay, is equal to 33.023. Okay, this is your correct. This is your point 0. So minus plus alpha it will be, okay, because this alpha will go to that sign, so just sign difference, and this 2 will come near to divide. Okay, like this completely is equal to 34.48. It is your phi. What you got? You got phi. Phi is 34.48. Yes, you got phi. Okay. So what you need now? W is equal to, you know the formula of feed, because you have feed with you. Laptop cut you have, and you have feed also. Your thickness you have. Okay. So but you need to find a width, because you need to find fs. How you need to find ft? Now we need to find out fc and ft. Okay, for it we do fs. This is how we can go through fs. We can go to our mature circle. Okay, through fs. So for that we need to find out our w. So that w is equal to, that is width of chip, d by, you have d by sine, yeah, by p. Okay, you have, this is the 2075 you have, because it is mentioned here. Okay, 75. Okay, so your d will be equal to now 0.75 divided by sine of 75. So your w will be equal to 0.7764 millimeter. Okay, okay, this will be a concept. So what is your fc? You have to find fc now. You have t1, you have, you have to find fc. Basically I told you, you have to find fc now. What is the formula? W2, which is your area, into tau s, which is your stress of the material, that is given, divided by sine phi. Okay, this concept is your area. Okay, so it is equal to, yeah, 0.7764 that we got, into thickness we already have 0.38, into ts we have 580, divided by what? We have sine. Sine is, you need to calculate a phi. Okay, it is 34.48. Yeah, this is the phi we calculated. Okay, so what it will be now? Your fs will be, just put it the formula, is 302.2663 Newton. This will be a force. Now what do we need to calculate? Ft and Fc. So what is your cutting force now? You need to remember the formula which is mentioned in that slide. Okay, it is very important to remember the formula. The Fc you can calculate directly from Fs. Fc will be equal to Fs into cos of beta minus alpha minus divided by cos of phi plus beta minus alpha. So it will be equal to 302.266. Just take answer. Cos of, what is my beta? We calculated from friction angle. Okay, just take 33.12. Okay, take correct. You can take correctly. So 34.48 you have, plus 33. Okay, this is the what we have. Okay, plus this point of formula. Okay, 33 minus 12. So the fc will come to be 4975195 Newton. This is your first answer. Okay, you got. Right now what you need to calculate, what? First force. To calculate now ft. Okay, probably not hard to calculate now ft. So how will calculate ft now? You have to calculate the resultant. Okay, r. You have to calculate the resultant. Okay, is that r? So how will we calculate r? You know what is fc. Okay, you know what is fc. What is fc? It is r cos of. You have to be very correct with your formulas. Okay, Boyle-Marchal circle diagram. Yes, okay. You know fc now. So you can get r from this. R will be your 497.5195 calculate divided by cos of 12 by 30, cos of what? Beta minus alpha, that is 33 minus 12, you know. Okay, please with everything we are reaching just at the end. Okay, cos of what is your beta? 33 minus 12. Okay, so your r will be, you got r now, 4 3, sorry, it's 5, not 4, which is 5, this is written correctly this way, 5 3 2.91 Newton. Okay, this 5 further, but we don't have. Okay, so it is actually 5 3 2.9155. Okay, 5.2. Okay, Newton. Okay, you got R. Again, after that you know Ft, because you know that Ft is equal to R into sine of phi minus alpha. No, beta. Beta minus alpha, because you are taking thrust force, and beta minus alpha is the angle that you get from merchant circle. Okay, so Ft is equal to, you know, R is 532. Okay, 532.9155 into sine of 33 minus 12, which is equal to, you know, to the 21. So just calculate. Ft will be 1901 Newton. Okay, so you got both of the answer. Okay, you got our this answer. Fc you got, and Fn, Ft also you got. Okay, you got both of the answer. So it is mentioned here. Okay, and after that question, what is asked? The question is exactly same, but what asked here? If the coefficient of friction is point, it is they mentioned, but what asked here? That is the question. Calculate a friction force and normal force. You already have. No. Okay, means what we already have, we already have r, so it is easy to calculate it, because the problem is same exactly. You can check, the problem is exactly same. Okay, from which you can get everything is exact same. Okay, just need to calculate the friction force and normal force. That is only the simple. It is here, it is written cutting force and thrust force. What we written here, friction force and normal force, you can calculate easily from r. Okay, because from the question number 27 we got r. Okay, we got this r, which is equal to, what is our r? 5 3 2. Yes, you can get this. Why what it got actually some different, means some 32.9 was a point. So what is we got is equal to 2.91, can be approximated to 533 Newton. Okay, okay, so what is your if now to find a friction force equal to r sine of 33, which is that, not 33, yes, 33 is correct, but it is your beta, it is mu, what 10 inverse of mu is exerted initially. Okay, so it will be 533 into sine of 33, so it will be 290 by 29 Newton. Okay, and what your Tn will become then, we r into cos. Okay, it's simple. Okay, but you have to calculate everything. Okay, you have to come like everything, you have to calculate r, fc. Okay, if we have to first calculate everything. So it will be cos of r into, what is your r? 533 into cos of 33. What it will be? Simple. 447.011 Newton. Okay, got answer for both. Okay, is mentioned here. If not see, this is mentioned. This is your correct answer. So how you calculated it? We first find out phi. We first find out your beta, then find out the phi. Phi you can get from Merchant circle equation. From phi, what we find out? You have to calculate Fs. We have Fc. Okay, we have Fc. Because as we have Fc, we have what we have got Fc we got and Ft we have. So from no, what we have? This mentioned we have this mentioned somewhere. We have we don't write everything. No? We just have so we just have Ts. Okay, we have Ts. We have right. We have Ts. Okay, so this problem we have Ts. They mentioned somewhere that Ts what particular Ts we have. Okay, so we have Ts. So from Ts what we can calculate, and we have our coefficient of friction. We have thickness, and you have T1 and D, which is actually having our area. What is that? That is not actually area, but from D you can calculate what is our what we need actually W into T. What we need width. What is that? Width is equal to, we just calculated. What is that? D by sine of the gamma P. Okay, it is cutting edge angle, right? Some cutting edge angle principle mostly. So it is mentioned there. So this is 75 principal cutting. So from that we can find out the W. From W we can find out the area. Okay, which is WT by WT by sine phi. Okay, from area what we calculate, we have Ts, so we calculate the force because we know what is stress, we know what is shear stress of the material. If shear stress of the material means after that you start cutting, so it will reach. So while cutting it will reach. So your stress is equal to force by area. Which force it is? Shear force. You know this fact. Okay. You know this your toy is equal to stress is equal to force by area, but which force it is? Shear force. Okay, Fs by area. Shear area. We have area and you have tau also. So what we calculate Fs. From Fs you have Fs now. So Fs, you know formula for Fc. This is big formula. It is Fs by cos of beta minus alpha divided by cos of phi plus beta minus alpha. From that we calculated the from that what we have, we know Fc is equal to what? Okay, this is equal to R of cos of beta minus alpha. From that we calculate R. If once you get R you can get anything. Okay, you to do everything to just calculate R. Once you calculate R you can get anything. Okay, that is most important, but it depends upon the how much what conditions you given. So you calculate the R completely, you calculate the R. Okay, after you calculate R it is simple. Okay, after that you can calculate Ft because it is simply is a formula which is equal to sine, you know. Okay, is equal to R into sine of beta minus alpha, and again you can calculate your F, which you need to calculate here, which is equal to R sine beta. Okay, and R and your N is equal to normal force is equal to R cos. Okay, beta. And what how we calculate the beta, that we know from Mercier circle. Okay, we have beta, we have rake angle. So you know Mercier circle diagram, that is 2 phi plus beta minus alpha is equal to 90 degree. Okay, from which we got it. And what is your Lee Shepherd? It is multiplied by 2, so we got Lee Shepherd. It is different. It is based on minimum power. Okay, within Mercier circle. So Lee Shepherd is different. So we don't use Lee Shepherd because only Mercier circle only, which I have mentioned immediately. But mostly we got this equation only. So from that, how it is we actually reach to our answer. Okay, you know how we actually reach to our answer. Okay, from this, everything we have to restore answer. Okay, it is time to stop. So thank you for listening. This is out. Okay, I will keep this everything and will send you these things. Okay, after just right now. Okay, we just save this and we'll close the meeting. Okay.